From IM Plus Electronics.
Yeah. So hello, friend. So let's start talk. Okay. So I'm Rahul Kumar here. I'm a lead engineer at IM Plus Electronics. Okay. So IM Plus Electronics is a Hollywood-based startup company. It's founded by the William IM, lead singer of the Black Eyed Peas band. Okay. And what we do, because William IM is a kind of a singer, so we build AI software for music industries, and we build hardware and the software both for the other industries like retail industry, telecom industry, and all the industry. Okay. So before I begin my talk, I will just start with one video of our application, and then.
Could you please send Chris an updated forecast report?
Note has been sent.
So we'll need to get that out as soon as possible.
Okay, sounds good. Omega, how many rose gold units are in stock in the San Francisco Distro Center?
500 units are currently available.
Great, thanks Omega. So Chris, are we good with the 500 or do we need to add more units?
500 will be fine, thanks.
Chris has sent an urgent email asking when the shipment will be arriving. Shipment is due to arrive next day at 2 p.m. Would you like me to respond to Chris's email to give him this information?
Yes, please. Omega, can you set up a meeting with Duncan and Carly while I'm in Chicago?
For what day?
Wednesday,
For what time?
2 p.m.
Duncan and Carly have been invited to the meeting. By the way, be sure to pack an umbrella, as it will be raining that day.
Thanks, Omega. Also, can you look up the best deep dish pizza while I'm there?
Searching for places now.
Okay, thanks for watching video. Okay, so what is Omega? Okay, so we started with the music first. So how our journey started? So we first built one hardware, our headphone. Okay, and that headphone got powered by our Omega system to recommend it to give a user a preference for which kind of music they have to listen. Okay, and by seeing their time and by their mood, we just preferring them which kind of music they have to choose. Okay. So after that, same algorithm we used on the different kind of domain like retail industries, their office automation work, and these all things. In this way, we just figure out that our music system, music AI platform, that whatever we build, that can be used in the various domain. Okay. So it's an artificial intelligence platform that can understand your mood. It can understand your voice, it can understand your different kind of a context. Okay. And then after is try to create a model behind that, and then after that model serves with your different kind of app. Okay. So our NLU platform, we will not call that Omega, we will call that simply as the NLU platforms. It can take your text input and it can take the voice input. Okay. It can understand music. Very first we started with the music. Then after we have the different kind of app interactions. So if you see the other NLU platform in a market, it can give you only one domain specific services. Okay. But we make our NLU platform is open for the different kind of apps like email, calendar, and different kind of news and different kind of web services. So you can easily integrate that thing with this NLU platform. Okay. It's an open API. You can create your own skill and you can integrate this thing with our Omega system. Okay. We have like an expressive dialog flow management. So you can decide that which kind of a behavior your app should do by the situation. Okay. So as I told you, like it can sense your mood, it can sense your voice, it can sense your tone, which kind of a tone you are speaking with Omega. Okay. So you can write the different kind of skills for that kind of situation. Okay. And you can put that thing inside a dialog flow management, all the dialog management system, so that your app should behave like that. Okay. So it's very expressive. So yeah. So this is the general architecture of our platform. So we can take input from our headphone, we can integrate with our app, and we can integrate with the web-based chat systems. So various clients of our telecom industry in Europe is using our chatbot to build their customer services automation Okay. And we also put the office automation software with the Slack so that you can employee can talk with directly to the Slack without interacting with the HR, and they can get all kind of a services. Okay. As I told, the music is our first preference, so we can provide like a 50,000 free music subscription to the user. So user can take our headphone, and then after he can get the free music subscription over that. Okay. So how we build this thing? Okay. So I told you like we have one platform. Okay. That platform you can build your own app on top of that platform. It's not like a service. Okay. So just like that, we are providing like a IM Plus platform portal, where you can define your own intent, entities, and the kind of a different kind of FAQ questions and dialogues. Okay. And I will describe that what's the intent and entity that you can interact with our platform. Okay. And we provide the same time with the hardware and software supports. If you don't have your own infrastructure, you can host in our infrastructure. So we can provide you like Elasticsearch, Kafka, Spark, Hadoop-based system, so that a small business can directly host their application on our infrastructure, and they can create their chatbots and the applications over our Omega platform. Okay. So let's start with the conversation flow. Okay. So what is actual conversation? So as I told you that we started with our music system, so we just commanding our headphone, play hello. So hello is a song. Okay. So our headphone can understand, yeah, I am saying like play hello. So it can go and find the kind of a model and check that, yeah, people are saying me to play some song. Okay. Hello is kind of I can introduce to other person, and I can say our NLU can understand, yeah, it's not like I am introducing someone. Okay. I am saying him to play some song. So it will go the music intent and try to find all the music related to the hello. Okay. And it will play. Okay. If I just say like play the song of MJ, so our NLU can understand that MJ, I am just talking about the Michael Jackson. Okay. And it can give a fast response without even giving the delay, and that song got played. Okay. So for that, we require to give some input to our NLU system. And before giving the input, I told you like this, I am saying to my NLU platform, play hello and play MJ song. Okay. So it can be pre-processed, like MJ means I am talking about the Michael Jackson, some artist. Okay. Hello means some kind of song that I am talking about. Okay. So this kind of a pre-processing we do in our NLU platform before entering into the actual NLU part. Okay. We have like intent classification flow. Okay. So if you ask some question like add something to my Outlook, okay, add this mail to my Outlook, okay, send this text to this guy. Okay. This kind of a question we can identify. Is it like an email workflow, or is a song workflow, or is kind of some kind of a retail workflow that I am talking about? Just like that you are talking about add 1 kg apple to my cart, okay, or same time you tell like add this thing to my Outlook. There is an add word in the two different contexts we are talking here right now. Okay. So this kind of understanding and this kind of a question we do in the intent classification. Same time I told like if you are doing intent classification, okay, you require to find a lot of intent inside that entity inside that intent. Okay. Because entity is kind of a core of all kind of a NLU system. Okay. You have to define your entity, which kind of a entity you are dealing with. Okay. So we have like a second model called like a entity extraction. By seeing the user question and the all the flow, we just identifying all the entity to that. Okay. Then after context awareness is one of the core in our NLU platform. Okay. Kind of we are dealing with a long conversation. So if you are buying our headphone and you are trying to interact with our NLU, so that whole day or whole week or whole month I have to with you only, because you are once you are wearing headphones, so we know that which kind of email you are using, which kind of shopping provider you are just always going, okay, which kind of retail industry you are dealing with. Okay. So we know that every time our chatbot will not ask you that if I am in UK and I will say that add 1 kg apple to my cart. So I know that you are just every day you are going Tesco, so I will just add in the Tesco's kind of shopping cart. If you are in United States, I will add in the Walmart. Okay. If I are in Singapore, I will add in the Red Mart. Okay. So this kind of a context awareness we are trying to teach our NLU engine, so that they can understand the user's geography, and then this kind of a behavior they can do. Okay. Dialog system is like a more about the development side, where user can define their dialogues. Like if you are a app developer and you are using our NLU platform to develop an app for your organization, so you will know that which kind of a flow you want. If you want some geographical information, then after you want to route something to the different place, you can just define. So we are giving a lot of kind of tools that you can easily interact with our dialogues. Okay. this is like our structure of our conversation. I told you like this, like I told you book a cab from airport to State Fort, okay, and then same time I am saying like find an Indian restaurant in between that. So I have to just say this question only once, like a book airport to State Fort and in between the Indian restaurant, so that our NLU can understand like in between the route, whatever restaurant they have to filter it and they have to give me the kind of all the information about that restaurants. So these are like a structure of the flow that if you are interacting with any NLU platform, these minimum three things you have to interact with that. Okay. This is a dialog management screenshot of our portal, where you can define all the dialogues, like your dialogue, which kind of response you want to give when your dialogue is completing. If dialogue is not completed, you have to go back to the previous dialogue. So we provide this kind of a portal where user can easily interact with each option of the dialogues. Okay. Yeah. So if I am saying like a lot of things, like you are dealing with music, you are dealing with a retail industries use case, you are dealing with your office automation use cases. So how we just do this all kind of work with single NLU platform. So we build only one single platform, they can deal with the 10 kind of a different kind of a use case. So data is the key. One key that we always have to just think about that, how to fit which kind of data to our NLU platform that can serve to the all kind of use cases. So we have like a data infrastructure, and then after we have the data management platform that built on top of Apache Spark. So we use Spark as our like a core building block for the all kind of data infrastructure, where we have like a streaming data, like if you are interacting with our headphones, that time all the text based, all the voice based information we are storing. Then after if you are chatting with our chatbots, we are storing the text based information. Then after same data, after crunching, we are putting on the training data set, so that we can collect all the data and then powered our NLU's training with on top of that data. Okay. So we have two machine learning branches where we do the traditional machine learning work with Apache Spark MLE, and we have the TensorFlow department who do all kinds of NLU with the latest kind of all neural network based artificial intelligence work. Okay. Yeah. So as I told, like data challenges that why we separated our branch into two different kind of department in a single domain. Like we do all the machine learning only, but we just separated two parts. First, data is not like a single form of data we are just consuming. Okay, we have text based data, we have the voice based data, and we have like some files that we are uploading lot of corpus of the different kind of a domain into our NLU system. So our data is not like a single format. So we require lot of data crunching, we require lot of annotation over that data, we require lot of labeling, then after we required lot of processing on top of GPU or CPU clustering. Okay. So these are like a data challenges that we faced, and we think like, yeah, this is the approach that we have to follow, like make a separate department, okay, where you can do like a traditional machine learning based work, and then after you do the all kind of a deep learning based of work. Okay. So collecting user data in real time. So this is like one of the portion of the code that I took from our system, okay, where we are creating like a memory for each user, like a context memory. Okay. So like I told, like it's like a subscription based NLU system, okay, where you just take our headphone or you take our voice box and you just interacting with that system, and we are just collecting your all information and just creating a memory in our system so that I can give you the fast response. Okay. So here you can see like you can interact with a different kind of a context. Okay. And context is not like a single context. You can talk with like a music, you can talk same time with a different use cases, and we will store all the things. And real time we will just collecting information and building kind of all the data model on top of that data, and it's try to fit into your system so that you can easily get the response back. Okay. Okay. So this is like our streaming system, and we are just kind of a batch system we are taking together. We are just crunching that thing and putting inside our historical data, and that data can be used for our system, that we can use like a simple Apache Spark streaming based system and the traditional machine learning, and we can take like a same Spark based kind of aggregation, and we can filtering out, and we can join with the different weather data and after geographical data, and we can create a model out of that. Okay. Okay. So this is our like a simple Lambda architecture that we in beginning we built. Okay. And we just do all kind of machine learning work on top of this Lambda architecture. So where this helped us, okay. So I told you like annotation work. This is like one of the hardest part we solved in very beginning. We just labeled all the data because we have like a music data, okay. So you have to label your data with your artist, your genres, your kind of a user's mood, okay, which kind of mood user want to, which kind of songs, okay. This kind of annotation you have to do on top of all data set, okay. So we have like a lot of music data available because it's like a music production company, so we have like a lot of licensing data and all the kind of historical data of all the music. So we created our own annotation set over that data, okay. So for that we use Apache Spark based system, okay. It's not like a streaming based system, it's like a normal Apache Spark based system that work with the Stanford NLU and these all things, and we just try to label all the data with that architecture, okay. Okay. So in data pipeline we are using this is one of our oldest kind of and currently also using like a music recommendation system with the Apache Spark one, okay. So in this we have like a system where we can feed data from the social network of the user, okay. Then same time we have our headphone that just collect the information from the user, and we are feeding into our Spark ML lib, and we are using this Elasticsearch to store all the scores of that data, okay. And now the newer system that we have built on top of the neural network TensorFlow, we are using the same data and we try to feed into our the newer TensorFlow system where we can give the more accurate result to our user, okay. So yeah, so deep learning. So why we moved from Spark based ML to the deep learning, and still we are using both together, okay, because this is like one of the questions that every user asks us, like why you are doing this thing, okay. So deep learning is the one of the current system that use like a neural network to train our data, okay, create our model and do all kind of system, kind of a prediction based recommendation and these all kind of system. So is deep learning is a system where you not required to label the data, okay. You just take a data, you create like a vector out of that data, and then after do all kind of algorithm over on top of that, okay. So this helps us to kind of remove our label data and directly feed that data into our system and understand data pattern, okay, which kind of a pattern our data have, so that you can use the same pattern into different kind of domain. Just like you think like you are just playing English songs, and then after same time you have to play the Spanish song and the German songs and some other songs, okay. So can your same model can be used for the different countries model? Yes, we can use the same model on the different kind of songs also using deep learning. Okay. So how it work? So it's kind of a feed forward network where you just first train your kind of a model, or you create a model, train that model, and then after check the accuracy. If that accuracy is not that much, you just send back to your neural network, add the training data set, and again try to do this kind of operation. So in the end you will find like yeah, your error rate is kind of reducing and you are finding the correct result. Okay. So for this, what the minimum thing is required for the any neural network? So we say like a word embedding is the kind of one of the topic that I picked. Okay. So how you using word embedding into the neural network? Okay. So word embedding is kind of a things like you take one any format of data, convert into the mathematical model. Like you just create a vector out of that, and then after try to make a relation between these vectors and create a formula on top of that vector, so that the different pattern will come. You can kind of correlate that pattern with your previous pattern, and then after you can just work on top of that. Okay. So there is a three methods that we are using. We are using a word to vector model right now. Okay, for our all the text based and the voice based kind of all the NLP. Okay. So what is this word to vector? Word to vector is kind of things you just take a data, okay, and try to create a vector and try to find the relationship between those two. So here is kind of one classical example. Every book have this one. So like you just plot this data into the kind of 3D plane, and you will find like yeah, mans and womens are like in same plane, kings and queens are in the same plane. Okay, so that you can predict yeah, like a different kind of a species will be kind of a same domain. So you, next time if the same data will come, you can give this kind of information to them. Okay, just like I told you like a songs. So if I take a Spanish lyrics, okay, and the English lyric, and try to create a word vector out of that, okay, and try to find the distance between the two Spanish and English songs cosine distance between the 2 points, okay, and then after that we can make our own formula that how you can relate these things. So this kind of work we did, and we try to find like, yeah, same model we can use the different songs, and we can give the accurate result out of that. Okay. Okay, so this word to vector give us the kind of a relationship between our 2 points, and we can make a relationship between the different kind of a domains data and kind of a music data and all the other things together. Okay. So if someone is interested in the create your own word to vector kind of algorithm, so we tried currently is in our work in progress. So we are creating our own kind of algorithms that can be do this kind of a vectorization. Okay. Yeah. So we are using TensorFlow now, and we are not using TensorFlow on Spark, but we are just doing the POCs over that. So TensorFlow is a normal framework, as you know, that is very popular in the machine learning. So doing all kind of a neural network processing. So it gives you like two things. So why we are very much interested in the TensorFlow, like that previously we have like a Spark development team. Then after we have not TensorFlow. So TensorFlow gives us the same feeling that we are dealing with the Spark code previously. So it have two things, kind of a one graph. Okay, then after you create that graphs are DAG out of that, okay, and then after you execute this kind of flow, okay. It's a mathematical libraries, then you have a lot of mathematical function, they provide higher order function, you can say, if you are comparing with the Spark, okay, and you create this higher order function in a sequence, like a lot of algorithms they already provide, you create that sequence and then try to run this sequence in a order so that you will get the result. So we find that, yeah, this framework is good, and we just directly ported our previous data into this model, this framework, and we find that, yeah, the result is very good, and we are very happy with the result. So we are using TensorFlow for our all the machine learning based work now with this TensorFlow. So as a TensorFlow have like a lot of API support. So we try with the Java, but stick with the Python right now. Okay. So TensorFlow is like one of the C API. After C API, we have a lot of layer like a Python APIs, then C++ client, and then Java client. Some guys are writing in a Scala client. We are also figuring out how to create our own Scala DSL over that TensorFlow, so that our previous machine learning codes we can port on top of that. Okay. So TensorFlow is providing kind of a lot of GPU support, okay, and the CPU supports, and distributed way also we can use. So just like we have like a terabyte of music data, we can directly port the terabyte of data for the training inside our TensorFlow in a distributed manner. Okay. So yeah, so after creating all the models, we have like one challenge, like how you'll serve the model. So we have around 200 models. Sometime back we had like for the supporting all kind of use case. Like we have the app interactions, we have different kind of a music interaction, and we have different kind of workflow. So we have like a 200 models. So how you'll host 200 model on web, okay, and we can power all kind of app. So we created our own model repository. And today's talk we saw like Apache Spark is also creating their own model, MLflow. Yeah, so this model repository can versionize all the previous model. Okay, you can track your model's behavior, how they are performing, which kind of data set it got trained, okay, and what's accuracy this model have. So we have our own model repository for the supporting this kind of all workflows. Okay. And same time we have the pipelines for the different kind of a department. They are dealing with their use cases, and we are just updating their our API based this model repository. They can easily upload their model files into our repository, and they can get served by their all use cases. Okay. So we have like a microservice layer is built on top of all the reactive framework, like it's Akka based framework that we used for serving all the APIs, and we have application layer written in the different kind of like application. We have iOS application, we have Android application, and we have web based all the SDKs, so that easily people can take our SDKs and they start building all the application over this Omega platform. Okay. So these are like a general architecture that we used to solve our all Omega use case, and that's it that I had. Okay. So if you guys have any question, then ask. Okay.
Thank you very much, Rahul. Yeah, any questions out there?
Sorry for maybe asking something tough. I see a lot of engines, including Amazon. They are developing other companies, Deutsche Telekom, Orange, and others. Also, maybe you know Samsung or LG. They had some issues, legal issues, sending the data from their smart TVs to their data center to process some images, some other stuff. So, first question is. What you offer or what differentiate your application by your competition? And the second question, how you guarantee user privacy?
Yeah. So we are dealing with some European telecom company. It's a very big company here in Germany. Okay. So how we are dealing with the security and how we are dealing with the data privacy. So as I told, like we are not like a cloud provider. We provide the whole platform and SDKs. So if a company, just like I'm giving example, like a T-Mobile is using our application for the supporting their clients chat application and all things. So we are going to their infrastructure and we are installing all the application there. Okay, we are not taking a single data out of that. As I told that we trained our NLU with the historical data and the current conversation of user data. Okay, that client itself provide that small set of data, and then after we created all the model and we just hosted it into their environment. So data is not going out of Germany, data is not going out of France, so it's living in their infrastructure only. So and all their behind their VPN. So we are not caring after providing this all kind of solution to on their premise. Okay. Yeah, Alexa. If you are using Alexa service, you have to just send your data to all Amazon. So that's things giving us some edge, and people are using our system. Okay, like a small company, there's some big company also. They don't want to give their data to Google, or they don't want to give their data to Amazon. They comes to us and they say like, take your SDK, install into our infrastructure. Okay, and we will on your system. So it's like we built voice box. Okay, just like Amazon Alexa. We just provide the full hardware to them. Okay, we have like open API layer over the hardware, so you can create your own application. Either you can write in C++, you can write in Go, and you can write in Java, and you can burn into our hardware, and we will just provide you the complete hardware. So it's your hardware, just you owns that hardware, like that. Okay, in Alexa you can't do these all things. You can't change their firmware and all the things. Okay. Only our headphone is not like changeable, because we give the music subscription. And it's like a free music subscription, so whatever we will provide, you have to use that headphone. No change in that.
Yeah, so one last question. You mentioned 3 models, Word2Vec, and there were 2 other, Glow or something else. So Word2Vec, was it run on GPU or do you run on CPU?
Yeah, we use GPU.
Okay, so okay, all right. Have you also explored other models like NMF?
So I given 2 more models there named there. So we are exploring that model, okay. And we are trying to create our own model also. So like we have a lot of data, so we can play with that data. So right now, just we are in the exploration phase.
This Word2Vec is a GenSim or the older version?
It's a newer version one we are using.
Okay.
Yeah.
Okay. All right. Thank you.
Thank you again, Rahul.